Welcome to my fourth video in Waves in Thermodynamics. I'm going to be answering just reflection and refraction in this video because it's such a large dot point. So let's have a recap on what we've learned so far. So mechanical waves need a medium to transfer their energy. When the medium ends or changes, the wave does not stop. Instead, the energy of the wave undergoes three processes. So the energy is reflected, absorbed, or transmitted. So reflection is when the light of a wave hits an object and changes direction, and you can see that in the diagram there. So this is when a light ray bounces off a plane, concave or convex mirror, and you can get the angle of incident and the angle of reflected ray would equal one another. Okay, so for a plane mirror concept there. Okay, so you need to have drawn the normal imaginary line which is perpendicular to the boundary of where the wave strikes the boundary, and you've got the incident ray equaling the reflected ray, which is called the law of reflection. So let's have a look here at a series of questions. 1. A ray of light hits a mirror at an angle of incidence of 46 degrees. What is the angle between the incident and reflected rays? Series of multiple choice questions or responses there. And 2. Consider the following diagram. If the angle of F is 130 degrees, then the angle of reflection is series of multiple choice responses. I'm going to give you the opportunity now to pause the video if you'd like to do this by yourself. Okay, and now let's answer them. And you can see here that your first answer is 92 degrees, which is 46 as your incident and 46 as your reflected, and the sum of them is 92. So your answer is D. And for 2, you've got F is 130. Now we'll work out that remaining angle on the left-hand side, or other than F, and it's 50 because 180 minus 130 is 50. So 50 occurs on that side and 50 occurs on the other side, which totals to 100 degrees. So that incident ray and reflected ray must be the same number, and the remaining is 80 degrees, so half that, so you got 40 degrees on either side, which is B. Refraction is when the change in direction of a wave as it changes speed in passing from one medium into another medium of different density. So during refraction, the velocity of the wave changes, the frequency stays constant, and the wavelength changes, and you can see that in those two diagrams. So for electromagnetic radiations undergoing refraction, it depends on the mediums, and I've got both of those scenarios there with the appropriate diagrams, so you can check that out there. Now, refraction and refractive index is the absolute refractive index of a medium, is the ratio of the velocity of the wave in a vacuum to that of its medium, and it can be given by n equals c divided by v, and I'm sure we're going to answer many of these questions in class. But let's have a look at the next one, which is Snell's law, which is sine I divided by sine r equals v1 divided by v2 equals lambda 1 over lambda 2, or wavelength, divided by n2, n1, which is the absolute refractive index of the medium. So let's have a look at 3 multiple choice questions, and yes, I can see there is a typo there where you've got 2 B's for question 3, so the top right hand side will be C. Okay, so let's have a look here. What causes the light to refract? Series of multiple choice responses. 2, a beam of light travels from air into a different medium. What of the following will refract light the least, for 2, and 3, which situation would light speed up? So if you like the opportunity to pause the video now before I answer them. Alright, let's have a look here. So for question 1, the answer is D. The light changes from one medium to another. This is what causes light to refract, and this is in my video that I just explained. 2 is D because it has the least density compared to the others. And 3, it's A because from passing glass, which is dense medium, to a less dense, it speeds up in air. So you got 3A. If you enjoyed watching this video, please hit the subscribe button or like. Any comments or any feedback's welcome. I've got a Module 1 and Module 2 playlist on kinematics and dynamics already, so please check them out if you already haven't. Thank you for your support.